Exercise 7a. Explain what you understand by a hypothesis test. So we'll discuss this one bit in detail. A hypothesis is a statement made about the value of population parameter. So first of all, we need to rewind what is population. What is population? Then what is population parameter? Population refers as a members of group or people or things in general. So this is a very light meaning for that. So members of group of people or things. Or bit advanced one, population is a collection of items under discussion. It may be finite or infinite. It may real or hypothetical. So this is another advanced definition, but we can state that population, it may refer to members of a group or thing. If you consider the 40 pens, or the pens are the population, or height of people more than 1 meter in UK. In that case, it's a group of people. That's it, clearly defined. So likewise, you can have a general sense on it. Then what is a parameter? Um, parameter is a data that describe it's a data that describes entire population. Do you think that you can think about a data like that? A data, a parameter. A parameter is a data that describe entire population. Okay, let's consider a population. Height of people in UK. So height of people in UK. Any value, that one that represent whole population, height of population, mean mu. So if you refer mean mu, using mu, the mean, you can express an idea about the height of the people using mean value. Now mu is a population parameter, mean. Now it can be regard to a height, or then another mean, weight of people in UK, or mean marks for a maths A level or chemistry. So with this figure refers to all the members of that population. So a parameter is mean is a parameter that describe entire population. So likewise, another parameter could be probability. We can tell 2/3 of A-level students pass maths paper. So then 2/3 of A-level students, this is referring to all population, this probability. Or it could be 10p coin population and probability of getting head. So hypothesis is a statement made about the value of a popular parameter. So we are telling in here height of all the people mu equal, let's say, 1.5 meter. So for weight W, mean weight is 100 or 85 kg, or the probability of getting head is half of that population. Getting head is half. In previous example, probability of voting, we work with that one 40%. So P equal 40%, 0.4. Now explain what you understand by the hypothesis test. So hypothesis is a statement made about the value of a parameter, of a population parameter, and so hypothesis still is a tool now. Hypothesis test use a sample or an experiment. If it is bias or unbiased, then we do experiment 20 times tossing, or likewise that A has a psychic power. Then we did 20 trials, so that is an experiment or a sample. Sometime if you talk about the mean, then you have to take a sample. So if you need to know about the population mean mu, it's sometimes difficult to find mu. Instead of that, we take a sample out of it and we get x bar. So we use a sample or an experiment to determine whether or not to reject the hypothesis. So explain what you understand by a hypothesis test. So now hypothesis is this. Hypothesis test is a tool to reject or not according to the sample or experiment, according to the data of a sample or experiment. Null hypothesis is not what we assume to be. This is the answer for the question part B. Define the null hypothesis and the alternative hypothesis and state with the symbol and used to it. So this is very straightforward. The null hypothesis is not what we assume to be correct. And we use H0, and the alternative as H1 tells about the parameter if our assumption is to be wrong. The part C is define the test statistics. The test statistic is used to test the hypothesis. It could be a result of the experiment. For example, probability. When we work with the probability, so X number of success. So that test statistics is number of success. It is a result of a experiment. Or from a sample, statistics from a sample. For example, we can't assume we have a population, so we can't measure the height of all people in England. It's so difficult. So then we will take a sample out of it. So this sample statistic is X bar. For relevant to mu, we can't, mu is the population mean, X bar is the sample mean, both are mean. Sample mean, this is population mean, this is sample mean. So population mean is mu, sample mean X bar. We are going to predict mu by looking at the sample mean. It's something like that. We can predict about the father by looking at the son. It's something like that. Uh, so population mean and the sample mean. When we consider like a result of A level students, yes, we have the facility to find the mu, the population mean, because we know each and every student who's at who's at the A level exam, and we can find the actual population mean. But assume that the weight of a number of deers in UK, so then in that case you can't measure of that. So then you have to take a sample. So in that case you can't measure that mu. Instead of that, measuring a sample mean, which is x bar. Then x bar is the test statistics. Here when you can see the probability, it's a number of out of total number, so it's a count. So it's test statistics will be number of success, number of failures, number of fails, number of tails. It is number of. Question number 2. Explain this is one tail or two tail test. So we know that H naught is alpha. Then we have two options: H naught less than alpha or H1. Null hypothesis greater than alpha, and H naught null hypothesis alpha. Then the alternative. So alternative is less than or greater than, and alternative is not equal to alpha. So those are one tail. One tail. This is two tail. Two tail mean we have to use both option here. So basically H1 less than alpha and H1 greater than alpha both. Instead of writing this one, we simply write this one. So this is one tail, two tail, and in here we are using uh, lower tail, and in here we are using upper tail. So then question number part E is H1 P greater than 0.8, one tail upper, and part B not equal to H1P not equal to 0.6, then two tail. Two tail mean lower and upper both. Part C, H1 P less than 0.2, so this is one tail lower. Question number 3. When you read the question, just think that how do you really do this experiment yourself, which will help to understand the questions. The Dimitri want to see whether the dice is biased towards value 6. Now, if a die biased towards value 6, how do you do experiment? Just bring into your head that how really you are going to do this one, and what is it basically. In general, we know that the dice population there. So in this population, we know that having same one side is have the probability same, and in particular die that is the hypothesis. So H naught is usually we know that is 1 over 6, but now in this case it is getting he's not sure about this. Now this is um, bias getting 6, getting value 6, bias towards value 6. It means when you put more times, it is getting more and more sixes. So assume it is, if we put 20 times, we if we put 24 times, which I can divide by 3, so then we are expecting 4 times 6, but it is getting more 3 or 4 or 5 or more that. So more and more mean it is in the upper side. So there is no any relation to 1 over 6 because we are counting the number of success. The experiment is different. So H1 is going to be probability greater than this one because we are going to use the upper side because getting more and more. Usually we need to get 4 times, but it could be 5, 6, 7 because it's biased towards getting more sixes. So then the text statistic should be uh, number of uh, sixes. So the okay number of sixes rolled in the 60 trials. So that is the test statistics. Question B is write down the suitable null hypothesis. Yes, usually we know that this is the standard. It's not a probability of getting 6 is 1 over 6. And the alternative is getting more and more biased towards 6. It means getting more and more 6. It means increasing. Number line is increasing to that size. So probability of getting greater than 1 over 6. Question number 4. She'll want to test see with a coin bias. She tosses the coin 100 times and counts the number of times she gets a heads. Shell says that her test is a probability. Yeah. So, for example, if you need to test a coin that whether it's biased or not, so what do? You know that in general, in the population, coins are unbiased. Coins are unbiased, and usually probability of getting head is half, or probability of getting tail is half. You can try either head or tail in both. So the test is you are tossing 20 times or 100 times, and if you get head times, if you monitor in head around 50 or 51 or 49, very close a figure, then probably the coin is unbiased. But if you instead of that probability of getting head, if you get 16 out of 100, or it is good 88 out of 100, both are unbiased. Now in this case, they didn't mention that to bias towards, and it can be lower or it can be higher. So in that case, it can be both sides. It means it can be less than or it can be greater. So we will write simply in this one, P is not equal to half. So then the test statistics so the test statistics is part A. This explain the mistake. She is telling that statistic is the probability of the coin landing on head. So the test statistics is test is the number of times coin lands on heads in 100 trials. Shell is describing what the experiment want to test rather than the test statistics. So B is suitable. Null hypothesis probability of is half, and the other one is H1 probability of not equal to half. So this is going to be 210. The bias can be to both sides. In the number line, it is lower tail or it can be upper tail. In question number 3, it is P equal 1 as but P greater than 1 over 6. This is H0 and H1. Question number 5. In a manufacturing process, the proportion of faulty article has been found from a long experience to be 0.1. So this is the story about the population. In the population, they say that the faulty probability of getting faulty one is 0.1. So in a long experience in the history, that's how we explain the population situation. Now we want to check that this is really true. How do you check this is really true? So you want to take a sample and then if you pick up 0 to 1, 2, 3, 4, 100 samples, and we believe that this is follow the binomial probability 100 0.1, and then we develop the probability and distribution, and there is a threshold. They have given 5% significance level. First of all, we know H naught is going to be H naught. This is 0.1, and the manufacturer wish to test. Okay, 5% significance level, whether or not there has been a reduction of the proportion of the fault. It means this amount is getting below. So H1 is probability of this is equal to 0.1. This is less than 0.1. So this is the null hypothesis, and so the threshold is 5% here. 5%. You can count in terms of the numbers 0, 1, 2, 3, 4, 5 up to 100, or you can count the probabilities add up. So the given threshold is 5%. Now, okay, what is the first question? Suggest a suitable test statistics. Yes. Number of faulties out of 100. Uh, A, let's say that it's a statistic is X. So this is going to be number of faulty articles in 100 units. 41 in 100 units. Part B, write down the suitable hypothesis. So null is always from the population. It says 0.1. Now we want to look at the alternative one is P less than 0.1. Explain the condition under which the null hypothesis is rejected. So how many they are going to pick? 8. Now, so test value is 8 now. Now this probability is less than 5%. The null hypothesis basically this, so 8 is within this 5. So 0, 1, 2, 3, when you take this is the 5% threshold. Let's say it has 13 or 14 something, I'm guessing. uh, so in that case, the 8 is inside this, so this 8 area, inside that 5% area. So probability of x less than or equal to 8. So all addition 0 plus 1 plus 2 plus 8 up to 8. In terms of, if I explain another way, 5% area is big, this area is smaller, this kind of one, so that it is within the threshold. So reject the null hypothesis. Question number 6, it is a water story. So there is a person A. So A is newspapers found out that they have a 55% watt. So H naught is P equal 55, and so this is, and due to certain reason they think that this is reduced now. Now they want to test this one, and the test statistic is the number of waters. So x number of voters or supporters. I think it is not voters, supporters. Number of supporters in 20 sample of 20. And part B, write down two suitable hypotheses. So H naught is 55 and H1 is less than 55. So we want P equal 55 and H naught P equal 55. They want to check whether this is reduced. P less than 55. And pass C, explain the condition under which the null hypothesis would be accepted. Now we are checking from the lower, this is a one tail, lower tail it's going to be. So the threshold is 2% significance level, and if it will accept this 7 is outside here. If 7 is inside here, then it is rejected. So we'll write in the accept form, if what is the test statistics now? 7. This is the test value. Probability of x less than or equal to 7 is greater than 2%, then 2 or more, then we accept the, if we accept the null hypothesis. I'll revise you again that upper and lower tail. From the lower tail, let's say the statistic is x and the value is b, and the significance level threshold is beta percent. So then probability of x less than or equal to b less than beta, then reject H naught. Probability of x less than b greater than or equal to beta, accept H naught. So likewise assume that this is x is a, and the threshold is alpha. So probability of x less greater than or equal to a less than alpha, reject h naught, and probability of x less than or equal to a greater than alpha, greater than or equal to alpha, accept h naught.